let's do question 20. So we want to weaken the argument. Again, when you do these questions, just work out the main conclusion first, okay? The main conclusion is pretty much in the first sentence here. Space exploration is a waste of time. Okay, and then let's try to work out the author's reasoning, how they've supported that central premise. When governments spend money on sending people into space, there's less to spend on helping people in need and on improving services for everyone. Scientists say that when they do experiments in space, they learn more about the universe, but their work would be more useful if it made life better here on Earth. So the main reason they've given is that the government is wasting money on space exploration, which, yes, it might help advancements and innovation in science, but it's not directly helping services and life here on Earth, okay? So basically they're saying that the government should probably spend more money on important things regarding life on Earth, such as maybe healthcare or transportation, instead of wasting allegedly lots and lots of money on space exploration. Because guess what? Rockets are very expensive, and training astronauts to go to space, that's also very expensive. How do we weaken this? Okay, how do we weaken this? Now, I just want to emphasize this part where they said government should spend money on things that actually improve life on Earth, implying that space exploration does not improve life on Earth. So let's go through the options. A, governments worldwide are increasing levels of education spending. That's not relevant, because still, this is about resource allocation and how the government is budgeting everything. If the government is spending, I don't know, billions of dollars on space exploration, even though governments are increasing levels of education spending, maybe it's not enough to compensate on all the money that's spent sending people out to space. So A is not really relevant. A is not going to be weakening the argument. Option B, work by space scientists on aviation has increased the safety of flying. This does weaken. Why? Because it directly shows us that even though you're technically doing research and work in space, you're still improving life on Earth, because now we have maybe perhaps more data on how to improve aviation safety, right? So that weakens the argument because it refutes this core premise that space exploration does not help life on Earth. It actually does, right? As shown by option B. Option C, the 1969 moon landing cost over $280 billion in today's money. Well, this is pretty much substantiating the claim that space exploration requires a lot of money, right? Money that might be better spent on other things. So that's not weakening, that's almost strengthening. D, experiments on plants in space have shown how we could grow them on other planets. Now, some kids might have been tricked by this option, right? Because they're listing an advantage of space exploration. But again, we have to remember the focus is on improving life on Earth, and knowing how to grow plants on other planets is not beneficial to life on Earth. So B is the best answer. Okay, B is the best answer for weakening the argument. Okay, question 21. At the start of the meeting, every member of the movie club gets one vote on the movie to be watched. Everyone must use their vote. The movie that gets the most votes is the one that is watched in that evening. This evening there are 21 people at the meeting. So 21 people at the meeting and 5 movies to choose from. Kate, the movie that we watch will need to get at least 5 votes. Samira, if the movie gets 11 votes, we're definitely watching it. Okay, so how about we just say the movies are called A, B, C, D, E to represent the 5 movies, and there's 21 people, so there's 21 possible votes. Now let's just assume the most extreme scenario, which is that all the movies are pretty much similar in terms of their popularity, and therefore there's an equal or relatively equal distribution between the votes. So what's 21 divided by 5? That's 4 remainder 1. Okay, so let's just say that each movie has a minimum of 4 votes. Okay, 4 votes. Now, obviously, we still have one last vote, so let's just say movie A gets that one last vote, 5. That's basically the minimum number of votes required for that movie to win, for that movie to be touted overall the most popular, and for that movie to be the one chosen to be watched. Okay, so basically the movie that we will watch needs to get at least 5 votes. Kate is correct, because we just assumed the most extreme scenario, which I might repeat, is that all the movies are relatively similar in terms of popularity, and therefore there's a relatively similar distribution of votes between the movies. Okay, in that case, still, you need to have 5 votes minimum to guarantee that that movie is chosen. Samira, if a movie gets 11 votes, then we'll definitely be watching it. Samira is correct, because let's just say, again, I mean, it should be kind of obvious, but let's just say we choose A, and it gets 11 votes. So that means there's 10 votes left for the other movies, right? Now, again, the most extreme scenario, let's just say B gets 10 votes and the other movies get 0 votes. Still, that would guarantee that A would be chosen, right? Does that make sense? So this is the most extreme scenario, right? Okay, so Samira is correct. Both Kate and Samira are correct, option C. So what we've done here is we've assumed the most extreme scenarios. Okay. Question 22, this one's a little bit challenging. We have a room measuring 3.2 meters by 3 meters to be tiled with a pattern tile like the one shown below. The tile is a square with side length of 0.25 meters. So this is the tile that we have to replicate over and over and over again in the room. So the tile has these dimensions. Okay, it's a square tile. And then we have a really, really large room, which obviously won't fit in this page, but let's just say it is like this big, and we're just trying to tile that room, okay? The room has dimensions 3.2 by 3 meters. So, first of all, you have to ask yourself, how many times will the tile fit along the width and also the length? Now, the width is just 3 meters and the length is 3.2 meters. Now, you can do several ways. You can work it out in several ways. You can convert the meters into centimeters. You can say that's just 320 centimeters, that's 300 centimeters, 25 centimeters, 25 centimeters, and then just divide, right? Alternatively, you could also just, I think we'll go down that route. But also, tip is know that 0.25 meters is quarter of a meter. So how many quarter meters will fit into 3 meters? Do the math, guys. How many quarter meters will fit into 3 meters? 12, because 4 quarter meters will fit into 1 meter, and then 3 meters is triple of 1 meter, so 12, right? So this times 12 gives you that. That's a bit of quick maths if you're short on time, but I'll just show you guys the proper working out. So this is just 320 centimeters by 300 centimeters, and that's 25 centimeters by 25 centimeters. So you want to divide, okay? So how many times will 25 go into 300? Just do that division on a scrap piece of paper. Again, I don't think this is the most efficient way. I would just recommend thinking in terms of quarter meters and how many times that will fit into a meter. But if you were to do the division, you'll get 12, okay? So got that out of the way, 12. So this will fit 12 times. Okay, so 12 times along the width. So there'll be 12 of these tiles, these particular tiles, fitting along the width of the room. As for this one, 320 is actually not divisible by 25, right? Which is why they said the tiles are laid out from edge to edge, but the last line needs to be cut for it to fit, okay? Because there's a bit of a gap missing. So what's 320 divided by 25? Well, 320 divided by 25, think about it logically, guys. 25 times 12 gives you 300. So that means 25, the next multiple of 25 is 25 more than this, which is 325. So obviously if you do 320 divided by 25, you're going to get 12, remainder 20. Okay, just use your head. 320 is 20 more than 300, and 300 is a multiple of 25. So if you do 320 divided by 25, you're just going to get 12, remainder 20. So this is actually equal to 12, but there will be a remainder of 20. Okay, so that means, and this is the thing that you have to focus on. If you do 320, so if we're talking about the length of 320 centimeters, 320 centimeters divided by 25 centimeters will give you 12 remainder 20 centimeters. So there will be a remainder which is 20 centimeters. And that is basically going to be that last line. That last line that needs to be cut for it to fit in, the 20 centimeters. So what will that tile look like? So if we were to just convert all of this into centimeters, right? We want it to be 20 centimeters. 20 centimeters as a fraction of 25 centimeters is what? What is 20 centimeters as a fraction of 25 centimeters? 20 over 25 is equal to 4 over 5. Okay, 20 over 25 is equal to 4 over 5. So we basically want 4/5 of this tile, okay, to fit in. So that will actually look like what? Well, this has 1, 2, 3, 4, 5 squares, so 4/5 will look like this, okay? Does that make sense? So if you go from, let's use a different color. If you go from here to here, that's the 20 centimeters that is remaining. That's the 20 centimeters that we need to chop off so that we can fit the last 20 centimeters of that bit. Okay, so the answer is going to be option B, because we're taking essentially 4/5 of that tile. 4/5 of that tile. Comment down below if that makes sense. Okay. Question 23. Lauren wants to join her school's basketball team. To qualify, players must be at least 140 centimeters. So clearly this is just a necessary condition, right? Because we have the words must be, so must be necessary indicator. So all members of the basketball team are minimum b-ball team players are all at least 140 centimeters. Now Miriam is wrong because Miriam says Lauren was 139 centimeters last year, but she's grown to 141 centimeters, so she will definitely be chosen. Miriam has confused a necessary condition for a sufficient condition. Just because you are at least 140 centimeters, that does not guarantee that you can be a basketball player. You can still be outside of that smaller circle, right? So remember, inner circle represents sufficient condition, outer circle represents necessary condition. Basically, if you're not in that outer circle, you can't be a basketball player, but just because you are in that outer circle doesn't mean that you're in the inner circle. Okay, so think about it. There's so many things that can still prevent Lauren from being on the basketball team. Maybe she's injured, maybe she's fractured her ankle, maybe she has some health condition stopping her from playing basketball. Okay, so Miriam is wrong. Best answer is going to be option C. Height might not be the only thing used to choose players for a basketball team, right? Maybe you actually have to have some athletic prowess. Maybe you actually have to know how to play basketball, right? What if Lauren doesn't know the rules of basketball? Okay, so there could be other conditions, other requirements for players to be on the basketball team. Okay, question 24. 3 switches are connected to a set of 4 lights. When a switch is changed, each of the light that it controls turns on if it was off, or off it was on. Okay, so we basically have red, green, blue, yellow lights. So let's do a bit of color coding. Whoops. Just bear with me, guys. So obviously when you're in an exam, you probably can't do that, so I will actually just go straight into a rough diagram. So we have red, green, blue, and yellow. And they're controlled by different switches. So switch 1 controls the red and green light, switch 2 controls the red, green, blue. Okay, so this is just the diagram that I would set up. Switch 3 controls the blue and yellow. Okay, so basically if you turn on one switch, it will turn the lights on or off. If all 3 switches are off, then all 4 lights are off. So let's just assume that all 3 switches are off right now. Which of the following is true? It is not possible to have all 4 lights on. That's false, because what if we turned on switch 1 and switch 3? If we turn on switch 1 and switch 3, then we'll have all the lights on, right? So option A is not correct. B, the blue light cannot be on when the yellow light is on. That's also false, because what if we just turn on light 3, right? That would turn on the blue and yellow. That makes no sense. Okay, so for option A, we can just turn on light 1 plus light 3. For option B, we can turn on light 3. So these disprove these options. Option C, the green light cannot be on when the blue light is on. Again, that's false, because switch 2 can turn on green and blue. So that is false. What about option D? The red light cannot be on when the green light is off. That's correct, because red and green, they're both operated by light 1 or light 2, and there's no difference between them. So we can't just have red on for green off. That's impossible, right? They're either both on or both off, okay? So D is correct. Okay, I have just 4 cards. The cards have a letter printed on each side. The cards can be set out to make the following words. no letter appears twice on the cards. Which one of the following words could be made using the cards? So you have 4 cards, okay? So you have 4 cards. That's really important to take note of. Now, 4 cards, 2 faces, okay? So that means we'll have 4 pairs. Does that make sense? 4 pairs, because we have 4 cards, 2 sides on each. So to work out what's going on, let's work out the 4 pairs, okay? So the best way to approach this question is to actually compare the different sets of words and look for similarities and differences. So I'm going to compare these 2 sets first of all. So the similarity is C, okay, and A. So that means O, T, L, and K are different. So what's going on here? It could be O is on the same face as L, or O is on the same, same card. So it could be O is on the same card as L, or O is on the same card as K. We don't have enough information right now, but I'm just telling you the different possibilities. Alternatively, we could have T with L or T with K. We don't know right now. Okay, so let's look at some other cards for further clarification. What if we looked at L, A, C, K, and these? So if we were to compare these, we know that L would be either with S or O. Previously, we know that L is either with O or T. So if L is either with O or T based on this, and L is either with S or O based on this, then L must be with O. Okay, so I know that was a bit confusing, but I hope that makes sense. L must be with O, because if you were to compare this first of all, we already eliminated C, A, so just ignore that. So O is either with L or O is with K. Here we know L is either with O or T, right? L is either with O or T in terms of different sides of the same card. Based on comparing these 2 cards, we can eliminate C and K, so let's just ignore that. And we know that L is either with S or O, because we don't know if A is with S or O. But the common similarity between them is the O. So that means L must be with the O. Okay, L must be with the O. L must be with the O. Okay, so one of the pairs is L and O. So that's very helpful. Now, because we know L is with the O, and we were to compare these again, we know that T must be with the K. Okay, because L is with O, so L is with O, so that means we can cross out that one. So that means T is not with L, T is with K. Okay, and then we know L is with O. When we compare these 2, A must be with S. Okay, and we know that A is with S, and also if you were to compare these 2, C must be with B. Okay, done. So these are the 4 cards. We'll have one card with L and O, another card with T and K, another card with A and S, and another card with B and C. So the question is, which of the following words could be made using the card? Can bats be made? No, because A and S are different sides of the same card, so we can't have A and S as separate letters. Can blot be made? No, because L and O are on the same card, right? Can cabs be made? No, because C and B are on the same card. Can cost be made? Yes, because we can have C, O, S, T. Perfect. Option D is our answer. Okay.